In this video, we are going to use the differentiation formulas to conveniently evaluate some derivatives so that we can write down the equation of a tangent line. Now let me start off with the reminder that we've previously discussed. The slope of a tangent line to a curve at a point is given by the derivative there. So with this in mind, if we wanted to write down the equation of that tangent line, something I'm starting off, I have some function, and I'm interested in the tangent line at a value x equals a. So if we sketch the tangent line, we notice the tangent line goes through that point on the graph, a comma f of a, and the slope of the tangent line is the derivative at that point, f prime of a. So in terms of writing down the equation of the line, we have a point on the line and the slope of the line. So the slope is f prime of a, and the point on the line is a comma f of a. And from a calculus perspective, this is exactly how we define a tangent line. The line going through the point a comma f of a with slope given by the derivative, f prime of a. So the point slope form of the line, y minus f of a equals the slope f prime of a times x minus a. Simplifying this out, I think the easiest form is y equals f prime of a times x minus a plus f of a. And I will always refer to this as the slope of the equation of the tangent line. And what I like about it is once you know the point A, you see there's really kind of two numbers that you need to fill in. What is the function value f of a? What is the derivative, i.e. the slope value f prime of a? So let's find the equation of the tangent line to the curve 2x plus 1 quantity squared at the point 1 comma 9. So the point that we have on our tangent line is 1 comma 9. So the 9 is really representing the value f of 1. What we need to do is determine the slope. Well, the slope is going to be the number f prime of 1, where f of x is the function 2x plus 1 quantity squared. So if f of x is the function 2x plus 1 quantity squared, it's not in an ideal form for us to differentiate, but what we can do is view it in one of two ways. You could write it as 2x plus 1 times 2x plus 1 and apply the product rule, but I think it's simpler to just maybe expand it all out and write this as 4x squared plus 4x plus 1. Now, when we determine f prime x, we go through and we differentiate it term by term. And I'm going to do so a bit more quickly in this example as we've worked through a few derivatives. You have the constant 4, and we multiply that by the derivative of x squared. So you have the 2 that comes down front, and the new power is 1 less than it previously was. So 2 minus 1 is 1. In the second term, we have plus 4 times the derivative of x, and the derivative of x we saw is just 1, plus the derivative of 1, which is 0. And note, you could have simply instead written this as 8x plus 4, but I wanted to make sure we see exactly what is happening to each term under differentiation. So this is 8x plus 4. The number we are interested in is what happens at 1. So f prime of 1 is 8 times 1 plus 4, which is equal to 12. So we want to write down the equation of the line going through the point 1, 9 with slope 12. So that would be y minus 9 equals the slope times x minus 1. So y is equal to 12x minus 12 plus 9. So in slope-intercept form, this is our tangent line. So let's apply the same exact procedure here to the curve y equals 1 over x at the point 1, 1. So if we're going to think here of as our function being, let's call it y of x this time, 1 over x. In order to write down the equation of that tangent line, we need the point on the line, which in this case is 1, 1, where the second 1 is really representing here, we'll call it y of 1. And we also need the slope. The slope would be the derivative evaluated at the x-coordinate of this point, so y prime of 1. In order to differentiate this, you could apply the quotient rule to the function 1 over x. Think of the top function as being 1 and the bottom function as being x. But it's much more convenient to first manipulate this algebraically, x to the minus 1, and now it's much simpler to differentiate. And in general, that's a very good thing to keep in mind. Many of these problems will have multiple approaches that you can take to the differentiation, but sometimes a basic algebraic manipulation makes the problem a bit easier for us to handle. So now using the power rule, we have that power of minus 1, so the power comes down front, and the new power is 1 less than was previously there. Minus 1 is minus 2. And you could simply have written here minus x to the minus 2, but I want to make sure once again that we all see exactly what is happening. And this would be the minus out front, and x to the minus 2 is really 1 over x squared. So the slope of our tangent line is going to be y prime of 1, which is minus 1 over 1 squared, which is the number minus 1. So the line going through the point 1, 1 with slope minus 1. So this simplifies very nicely to be y equals minus x plus 2.